Alright, it's tough to see here and draw real detailed, but I'm going to attempt to show you how to graph any function that has a radical in it. And the way we're going to approach this is not all that different from how we approached parabolas or absolute value or anything of that nature. I want you to look at this function, and I want you to look at kind of the main part of it right here. Let's take it right there. And I want you to ask yourself, what number could I plug in for x that would make that stuff equal 0? Not too worried about the -1, just the x plus 2. What makes that equal 0? And the answer is -2. Now, in previous lessons, we talked about how that's the vertex. With radicals, we don't necessarily call it the vertex, but it is a special point. So that's what I'm going to do. I'm going to put -2. And then what we usually do is we pick some numbers kind of close to that to see what's happening. So I'm going to go ahead and pick -3, -1, and 0. And now, once you see the pattern here, you might be able to make some shortcuts and go a lot faster, but I'd like you to see where things come from. Okay, so let's look up and figure out some y values. If I were to take -2, we'll start with this one right here, and I put that into my function, I'm going to get the square root of -2 plus 2 minus 1. And the square root of -2 plus 2 is just 0, and 0 minus 1 is -1. Okay? So -1 is my value. I'm going to come over here and I'm going to find -2, -1. Looks like it's going to be right about there. Okay. Now, let's try some other numbers. If I put in -1, I'm going to have the square root of -1 plus 2 minus 1. Now, -1 plus 2 gives me 1. Square root of 1 is 1. And 1 minus 1 is 0. So -1, 0, that's one of my coordinates. -1, 0 would be right about here. Right now you're starting to go, oh, maybe that's a straight line. Well, no, it's not. Keep going. Don't just use 2 points. Otherwise, anything could look like a straight line. Let's plug in 0. So if I plug in 0, I get the square root of 0 plus 2 minus 1. That's the square root of 2 minus 1. And the square root of 2 is like 1.4 something. It keeps on going. So let's just round it off a little bit. Say 1.4 minus 1, which would be 0.4. So I'm going to graph 0 and 0.4, which is going to end up somewhere in this range. Okay. Now, what about the other way? What about over here? If I put in -3, the square root of -3 plus 2 minus 1. When I do this part, I get the square root of -1, which is an imaginary number. It doesn't have a real value that we can graph. So this is imaginary. I'm pretty much going to ignore that. It doesn't exist on this graph. Now that's going to make this a little bit different than most of the functions you've dealt with. I'm going to take this function and connect the dots, and what I see is it kind of goes like this, and then it sort of flattens out, but it still keeps climbing a little bit. And that's what a square root function looks like. Now, up until this point, you've dealt with a lot of what we call continuous functions. They kind of go forever in both directions. Well, this one doesn't, and for obvious reasons. Okay, the function will not allow it. Excuse me. If I get a number to plug in for x that happens to be more negative than -2, there simply isn't a real answer to get. Okay, my function basically stops right there. It's like there's an invisible boundary and it just quits right there. It does not exist over on this side over here. It just stops. Now what we call that is a domain restriction. This word domain bothers a lot of people. They don't quite understand what we're saying. All we're asking is what sort of x values work or what sort of x values don't work for this function. And up until now, you could plug almost any number you wanted into a function as x and get an answer for y. It was continuous in all directions. Well, now we're going to start hitting ones that have some restrictions or certain numbers that just don't work. So for this one, I would say my domain is x has got to be greater than or equal to -2. Okay, it could be equal to -2. We saw there's a spot there where that exists, but once we get any lower than that, it doesn't work. So that's all I'm saying with domain is which x coordinates will work, or sometimes it's easier to say which ones don't work, and we'll get into some of those cases down the road a bit.